Namaskar and I welcome all of you to my YouTube channel. This is lecture number 3 on magnetic properties of solids. Today I am going to teach you two important topics. First one is reasons behind magnetism and second one is an introduction to diamagnetism and diamagnetic materials. So without wasting time, let's get started. Topic number 1, reasons behind magnetism. Students, there are mainly three reasons behind magnetism. First one is due to orbital motion of electrons in their atomic orbits. Number 2, due to spin motion of electrons about their own axis. And third one is due to change in orbital motion of electron in presence of external magnetic field. Now let me write these points. There are mainly three reasons behind magnetism. Number 1, due to orbital motion of electrons in their atomic orbits. Number 2, due to spin motion of electrons about their own axis. Number 3, due to change in orbital motion of electrons in presence of external magnetic field. This reason number 3 is present in all atoms in presence of external field. ठीक है? So this is present in all atoms in presence of external magnetic field. However, in addition to this, magnetism can arise due to intrinsic spin magnetic dipole moment of nucleus also. However, this value is very small and can be neglected. So note, in addition to this, magnetism can arise due to intrinsic spin magnetic dipole moment of nucleus also. However, this value is very small and can be neglected. ठीक है. Now let us understand how net magnetic dipole moment of a bulk material depends on external magnetic field. Students, in absence of any external magnetic field, a bulk material does not have any net permanent magnetic dipole moment. It is because in this case all the atomic dipoles will randomly oriented due to thermal agitation. Now let me write these points. So if H is equal to 0, H means external magnetic field is equal to 0, then net magnetic dipole moment of the bulk material will be 0. ठीक है. So in absence of external magnetic field, a bulk material does not have any net permanent magnetic dipole moment, because all the atomic dipoles are randomly oriented due to thermal agitation. However, if we apply external magnetic field, then all these atomic dipoles will try to align along the field direction. As a result, this bulk material will have a net magnetic dipole moment. So if H not equal to 0, that means if we apply external magnetic field, then the bulk material will have net magnetic dipole moment. ठीक है. So in presence of external magnetic field, a bulk material will have a net permanent magnetic dipole moment, because in this case all the atomic dipoles will try to align along the field direction. So as a result, this material will have a net permanent magnetic dipole moment. Now let us move to next topic. The next topic is some important points regarding diamagnetism. Students, diamagnetism is observed only in those materials in which net magnetic dipole moment is 0. ठीक है. Number 1, diamagnetism is observed diamagnetism is observed only in those materials in which net magnetic dipole moment is 0. That means for this type of materials mu net is 0. Okay? Number 2, diamagnetism arises due to change in orbital motion of electrons around the nucleus in presence of external magnetic field. Number 2, diamagnetism arises due to change in orbital motion of electrons around the nucleus in presence of external magnetic field. This is reason number 3 of magnetism, reason number 3 behind magnetism. Number 3, diamagnetism is a very weak effect. Diamagnetism is a very weak effect. Okay? Now let me explain some important points regarding diamagnetic materials. Number 1, a diamagnetic material always repel the external magnetic field. It is because in external magnetic field a diamagnetic material is weakly magnetized in a direction opposite to the field. That means if we apply the external magnetic field along this direction, then this diamagnetic material will be magnetized in opposite direction. Okay? So first let me write these points. Number 1, a diamagnetic material always repel the external magnetic field. It is because in external magnetic field a diamagnetic material is weakly magnetized in a direction opposite to the applied field. Okay? Number 2, the relative permeability of diamagnetic material is less than 1. The relative permeability of diamagnetic material is less than 1. That is mu r less than 1. Number 3, the magnetic susceptibility is negative and small, and it is independent of temperature. The magnetic susceptibility susceptibility is small and negative. It is independent of temperature. So, if we plot a graph between magnetic susceptibility and temperature, then we will get this type of curve for diamagnetic materials. So, here we have seen that the magnetic susceptibility of diamagnetic material is negative and independent of temperature. Okay? Susceptibility versus temperature curve. Finally, please note down some important points. Note number 1. Students, in my previous section, I already mentioned you that a diamagnetic material always repel the external magnetic field. So, therefore, if we suspend a diamagnetic rod freely in between two poles of a strong magnet, then its axis becomes perpendicular to the magnetic field. So, in this case, the direction of magnetic field and direction of axis of the diamagnetic material will be mutually perpendicular. Now, let me write these points. If we suspend a diamagnetic material freely between two poles of a strong magnet, then its axis becomes perpendicular to the magnetic field. Okay? Number 2. Again, if we place a diamagnetic solution or diamagnetic liquid in a U-shaped tube and one arm is placed in between two poles of a strong magnet, then level of liquid in this arm will be lowered. Okay? And level of liquid in this arm will going up. Okay? Now, let me write these points. Number 2. If a diamagnetic solution is placed in a U-shaped tube and one arm is placed in between two poles of a strong magnet, then level of solution in that arm will be lowered. Note number 3. Some examples of diamagnetic materials. Some examples of diamagnetic materials are helium, neon, argon, copper, gold, silicon, germanium, etc. This is all about today's video, and I hope that you have learned a lot from this video. In my next lecture, I will explain the Lenzman's classical theory of diamagnetism. ठीक है?